Hello everyone, we're going to be solving Project Euler Problem 2, which is titled Even Fibonacci Numbers. This problem states that by starting with 1 and 2, the first 10... Oh, I'm missing a line. So each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms of the sequence will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. By considering the terms in the Fibonacci sequence whose values don't exceed 4 million, we need to find the sum of the even valued terms. Right? So most people solve this by generating every Fibonacci number and filtering the even ones. It works, but it's very dumb. So we're going to skip 2/3 of the work. Wink, wink. So if we use the normal sequence of the Fibonacci numbers where you start with 2 1s, we'll end up with this. And now we're going to look at the parity of these numbers, which means are they odd or even? And we will end up with this. Because 2 is even, 8 is even, and 34 is even. And you'll notice every third term is even, which is fantastic. It can really help us with this problem because we need the even numbers and we've spotted a pattern for them, right? So that just means we can jump directly between even terms rather than generating these two odd ones in the middle, and it'll save us a lot of time. So we're going to start like this. 2 and 8, because that's our first two even Fibonacci terms, and we're going to set the total equal to the sum of them because the point is we're going to generate the next one and add it on and generate the next one and add it on. It just avoids double counting or not counting them at all, right? So the important part here is this recurrence. So this is the formula right here for generating the next even term in the Fibonacci sequence. It goes f subscript n plus 1 equals f 4 lots of f subscript n plus f subscript n minus 1. I'm not going to derive this because it's a pain to type and it will also take me way too long when I want to keep these videos relatively within 5 minutes. But yeah, just know that this works. You don't need to know how. If you want to, I've gave it to you there. You can search it up, right? So the next question is, why am I declaring the new values for my variables like this rather than doing f1 equals and f2 equals? And this is because this is a really cool Python trick where, because obviously if I'm declaring f1 as f2 and I need to use the value of f1 to figure this out, well then that would just become f2 if I did it under normal circumstances. So I would have to create a temporary variable which I call f1, and then I would do 4 times f2 plus temp, which is just really annoying, right? This is a lot cleaner. It's really nice. So we're going to put this in a while true loop. It's an infinite loop, and the reason it's an infinite loop is because I don't want to check if f2 exceeds our upper limit here. Because if I do that, basically, what I'm going to end up causing is the first time that f2 exceeds 4 million, since I'm generating the new value of f2 within this loop, it will include a value which is greater than 4 million in the sum. Because we're checking it here and then calculating it here. That's the wrong way around. We want to calculate it and then check it to be precise, right? So we're going to make this an infinite loop, and then we're going to do if f2 is greater than or equal to 4 million, we're going to break out of the loop, right? And then the next part is gorgeously simple, and we've solved it. We just do total plus equals f2, and this will do the rest of the work for us. So now all we have to do is print total, and we've done it. That is indeed the solution. Thank you for watching. Bye-bye.